The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to go on and take a look at section 7.4, which is adding and subtracting fractions or rational expressions with unlike denominators. So let's look at some basic examples and then go on from there. So let's say we have y divided by 4 plus 3y divided by 5. In order to add two fractions, we need to have the same denominator. So the first thing we need to do for this problem is to find the least common denominator of 4 and 5. 4 could be prime factored into 2 times 2 or 2 squared. 5 prime factors into just 5. So the least common denominator would be 2 squared times 5 or 4 times 5 or 20. Now that we know the least common denominator, the next step is to take each of the original fractions and build them up to new fractions that have the same least common denominator being 20. So y over 4 equals what over 20? Well, if we multiply the denominator by 5, we get 20 in the denominator. Whatever we do to the denominator of the fraction, we must do the same thing to the numerator. So y over 4 becomes 5y over 20. Moving to the second fraction, we need to take the 5 in the denominator and multiply it by 4 to make a new denominator of 20. But whatever we do to the denominator of a fraction, we have to do to the numerator, which means our new numerator is 12y. So y over 4 builds up to 5y over 20, and 3y over 5 builds up to 12y over 20. Now we have two fractions with the same denominator, so we add the numerators. 5y plus 12y is 17y over the common denominator. Now, can we reduce that fraction 17y over 20? And it turns out that we can't, so this would be our final answer. All right, let's take a look at another example. We have 6 over n squared minus 2 over n. So the least common denominator of n squared and n would just be n squared. Well, they say on the farm, if it ain't broke, don't fix it. So 6 over n squared stays as 6 over n squared, but our second fraction needs to have a denominator of n squared. So what do we need to do to 2 over n so that the denominator is n squared? Well, we'd multiply the denominator by n, which means we'd also multiply the numerator by n. So now our new numerator is 2n. Now that we're subtracting two fractions with the same denominator, we're going to subtract the numerators over the common denominator. And I can't reduce this. I could factor a 2 out and get a 3 minus n over n squared, but that still wouldn't allow me to reduce any common factors, so I'll just stop there. Okay. 15 divided by 16a minus 3 over 4a squared. 16a would be 2 times 2 times 2 times 2 times a, or 2 to the 4th times a. 4a squared would be 2 times 2 times a squared, or 2 squared times a squared. So the least common denominator is the product of the highest power of each different prime factor within the different denominators. So my highest power of 2 is 2 to the 4th power. My highest power of a is a squared. 2 to the 4th power is 16, so my least common denominator is 16a squared. So back to my original subtraction problem, my new numerators are 16a squared and 16a squared. The first fraction, the original denominator is 16a. I need to get to 16a squared. So I'll multiply the denominator by a to give me 16a squared. But that also means I need to multiply the numerator by the same number, that is a, or the same variable. So my new numerator becomes 15a. So 15 over 16a becomes 15a over 16a squared. Now the second fraction, I need to turn 4a squared into 16a squared. So I'll multiply the denominator by 4. Consequently, I'll multiply the numerator by 4, and my new numerator is 12. All right. So now I have two fractions with the same denominator. So I'll subtract the numerators over the common denominator. So I get 15a minus 12 over 16a squared. Well, again, I could factor a 3 out of the numerator. However, that doesn't get me any common factors, so I'll just go back to that. But I always want to check because some of these will reduce once we've combined them. Okay, let's see here. We have 5 divided by p squared minus 9 plus 2 divided by 3p plus 9. So to find the least common denominator of p squared minus 9 and 3p plus 9, we will factor each denominator. P squared minus 9 would be p plus 3 times p minus 3. 3p plus 9 would be 3 times the quantity p plus 3. So my least common denominator, I need a single 3, a single factor of p plus 3, and a single factor of p minus 3. So my first fraction becomes, well, my new numerator becomes 3 times p plus 3 times p minus 3. And, excuse me, my new denominator, I think I said new numerator. And my new denominator for the second fraction, again, becomes 3 times p plus 3, p minus 3. Okay. So this has been changed into what's below it. That's been changed to what's below it. What am I missing in that first fraction? I need a 3 on the bottom and a 3 on the top. So my new fraction has a numerator of 15. The second fraction is missing a p minus 3 on the bottom, so it needs a p minus 3 on top. So my new numerator becomes 2p minus 6. Now I'm adding two fractions with the same common denominator. So I'm going to add the numerators. So I'm going to get 15 plus 2p minus 6 over the LCD. Okay. Combining like terms, I'm going to get 2p plus 9 over the LCD, which I'm going to write out now. Now, I can't factor 2 plus 9. There's no common factors with the numerator and the denominator, so it doesn't reduce. So that's as far as we can go with that problem. All righty. Let's see here. Here we have 9 divided by 2c squared minus 2c minus 5 divided by 2c minus 2. So we're going to factor each denominator in order to find the least common denominator of the two fractions. Let's see, 2c squared minus 2c, I can factor out a 2c and get a c minus 1. 2c minus 2, I can factor out a 2 and get 2 times c minus 1. All right. So the least common denominator would be 2 times c minus 1. It turns out that the first fraction already has that least common denominator, but the second fraction doesn't quite. What's missing? A c. So my new numerator becomes 5c, and I end up with 9 minus 5c over 2c times c minus 1. And there's no common factors that I can reduce out, so that's as far as we can go. All righty. Let's see here. Let's take a look at this problem. T plus 5 over t minus 5 minus the quantity t minus 5 over t plus 5. T minus 5 is factored completely, t plus 5 is factored completely, so my least common denominator is going to be t minus 5 times t plus 5. So my new denominator, t minus 5, t plus 5, t minus 5, t plus 5. Okay. My first fraction, I'm going to need to multiply the bottom by t plus 5, consequently the top by t plus 5 as well. And then multiplying that together, I'm going to get t squared plus 5t plus 5t plus 25, which is going to give me t squared plus 10t plus 25 over t minus 5 times t plus 5. Okay. Second fraction, I'm going to have to multiply by t minus 5 over t minus 5. So now my denominator is t minus 5 times t plus 5. And my new numerator, foiling that together, is t squared minus 5t minus 5t plus 25. So I get minus t squared minus 10t plus 25 all over t minus 5 times t plus 5. Now we have a situation that I kind of warned you about yesterday. We've got this numerator minus that entire numerator over the least common denominator. So my next step is going to be t squared plus 10t plus 25 minus the quantity t squared minus 10t plus 25 over the LCD. Okay, so now I'm going to distribute the subtraction, and I'm going to get, let's see if I can find room here, t squared plus 10t plus 25 minus t squared plus 10t minus 25 all over the LCD. All right, combining like terms, the t squared and the minus t squared would cancel. The 25 and the minus 25 would cancel, and I'm left with 20t over t minus 5 times t plus 5. And nothing will factor out further. Hang on a second here. And let me see. Yeah, so that's as far as I can go with that one. All right, let's take a look at another problem. This is, let's see, 4 divided by s squared plus 5s plus 4 plus s divided by s squared plus 2s plus 1. Factoring the first denominator, I get s, and s plus 4 plus 1. So the new factor denominator looks like that. And then the second denominator, I get s plus 1 times s plus 1. So the new factor denominator looks like that. Well, my LCD, oh, this could be written s plus 1 squared. So my least common denominator, I'm going to have an s plus 4 and an s plus 1, but I've got two of them on the fraction, in the fraction on the right side. So my LCD is s plus 4 times s plus 1 times s plus 1. Okay. So what do I need here? Well, first of all, let's see. My new denominator is going to be s plus 4, s plus 1 squared, s plus 4, s plus 1 squared. Sorry, my s's look like 5s there. So the first fraction, I need what, an s plus 1 on the top and the bottom. So my new numerator is going to be 4s plus 4, distributing the 4. Okay. The second fraction, I'm missing, let's see, I need an s plus 4 on the bottom and on the top. So my new numerator is going to be s squared plus 4s. Okay. So now I've got two fractions with the same common denominator. So I'm going to add the numerators, 4s plus 4 plus s squared plus 4s over the LCD, combining like terms, s squared plus 8s plus 4 over the LCD. So then the question is, can I factor s squared plus 8s plus 4? Okay. Well, let's see if we can do that. We would have to have s and s. We'd have to have a product that's 4 and a sum that's 8. Well, the only product that give me 4 would be 4 and 1 and 2 and 2 to give me a positive sum. So this doesn't factor any further. Okay. So that means our final answer, let's go back here and erase this. Our final answer is going to be s squared plus 8s plus 4 over s plus 4 times s plus 1, the quantity squared. Okay. All righty. Let's see here. Let's take a look at this one. 1 divided by c plus 6 plus 4 divided by c squared plus 8c plus 12. The first denominator is factored as far as we can go. The second denominator can become c plus 6 times c plus 2. Okay. So now I see that my LCD is c plus 6 times c plus 2. So I'm going to get c plus 6, c plus 2, c plus 6, c plus 2. The first fraction is missing a c plus 2 in the denominator. So I also need a c plus 2 in the numerator, which means my new numerator will be 1 times c plus 2, or just c plus 2. The second fraction already has the least common denominator, so I'll just bring down the numerator as well. So now, adding the two fractions with the same common denominator, I get c plus 2 plus 4 over c plus 6 times c plus 2. Combining like terms, I get c plus 6 over c plus 6 times c plus 2. I can then reduce out the c plus 6's to 1 over 1. Now be careful. Let's see. I need to be careful. I wrote a c that looks like a 6 there. Okay, this is C plus 2. Okay, so the C plus 6 on top and the C plus 6 on the bottom cross out, and we have 1 over C plus 2. We're not canceling them, so there's still that 1 in the numerator, okay? Yeah. So it's 1 divided by C plus 2. That's not the same as just C plus 2, okay? So you've got to have that 1 in the numerator as well. Okay, let's see here. Let's take a look at this example. We've got 9n over m plus 4 plus just n. The implied denominator of that second fraction, if you were to write it as a fraction, would just be a 1, right? So it's like over 1. So my LCD is just going to be m plus 4. So the first fraction remains the same. The second fraction, we're going to multiply the denominator by m plus 4, consequently also multiplying the numerator by m plus 4. So now distributing, my new numerator becomes mn plus 4n. So now I have two fractions with the same common denominator. So I'll add the numerators, 9n plus mn plus 4n over m plus 4. Combining like terms, I get 13n plus mn over m plus 4. Now, I could factor an n out of the numerator, but doing that would not result in having a common factor in the numerator and the denominator that I could reduce. So I'll just go back here. But again, I always want to check that just to make sure there's something I didn't miss. Okay, now let's look at another situation. 4 divided by b minus 6 plus b divided by 6 minus b. Now, we've looked at this situation previously. If we had something like b minus 6 over 6 minus b, that's that whole thing with the doggies and the kitties, and it all equals -1. However, in this case, we don't have them in that same situation. But rather than have the LCD b minus 6 times 6 minus b, we can make it less complicated by doing the following. Let's see. First of all, I want to erase this so I have more room. b minus 6 and 6 minus b are opposites of each other. That's why dividing one by the other gives us -1. So what I'm going to do, I'm going to leave the first fraction alone with the denominator of b minus 6. And I'm going to take the second fraction and I'm going to multiply it by -1 over -1. If you take a number times -1, you get its opposite. So what this gives me now is 4 over b minus 6 plus -b over -6 plus b. Again, distributing the -1 over here, okay? But I could also rewrite that, oops, as -b over -6 plus b would be the same thing as b minus 6, right? So what have I done? I've changed that to match that. So now I've got 4 minus b over b minus 6. And that's as far as I can go with that one. Okay, but I assure you, if we had gone with an LCD of b minus 6 times 6 minus b, things would not have been quite so nice. Okay, let's see here. Let's take a look at this one. X divided by x plus 1 plus x minus 1 over x. So be careful, because as we talked about before, this x is not a factor, whereas this one is. So if we were to factor the entire denominator of the first fraction, we still get x over x plus 1. The second fraction is still x minus 1 over x. So our LCD has to be an x plus 1 times an x. Okay. So this becomes x times x plus 1. This becomes x times x plus 1. Over here, I need an x over an x. So the new numerator is x squared. Over here, I need an x plus 1 and an x plus 1. The new numerator is going to be what? X squared plus x minus 1. That's that difference of two squares. So now I'm adding two fractions with the same denominator. So I'm going to add the numerators, x squared plus x squared minus 1 over x times x plus 1. Combining like terms, I get 2x squared minus 1 over x times x plus 1. And the numerator does not factor. That's not the difference of two squares. Okay, so that's as far as we can go. All right, let's take a look at another one. We've got 5 over 9x plus 4 over x plus 6. So the factoring of the first denominator, you'd have what? 3 squared times x. And the second denominator is still just going to be x plus 6. The second denominator, the x isn't a factor, the 6 isn't a factor, just the whole thing. So my LCD is going to be basically 9x times x plus 6. Okay. So 9x times x plus 6 plus 9x times x plus 6. I need an x plus 6 over x plus 6 on the first fraction. So my new numerator is 5x plus 30. I need a 9x over a 9x on the second fraction. So my new numerator is 36x. I'm now adding two fractions with the same least common denominator. So I'm going to add the numerators. 5x plus 30 plus 36x over 9x times x plus 6. Combining like terms, 41x plus 30 over 9x times x plus 6. 41x plus 30 doesn't factor any further, so we can't do anything else with it. All right, let's see here. Trying to find one to do next. Where did it go? Anyway, so that's as far as we can go with that one. Okay. Let's do some lookalikes. Part A says 5 over 2x plus 4x over 15. Part B says 5 over 2x times 4x over 15. So when we're adding two fractions, we need a common denominator. 15 factors down to 3 times 5. So basically our LCD is 2 times 3 times 5 times x, or what? 30x. So I've got to do, what do I need here? I need a 15 and a 15, so 75. And I need a 2x and a 2x, so 8x squared. So we end up with 8x squared over 8x squared plus 75 over 30x. Now, I can't factor 8x squared plus 75, so that's my final answer. But multiplying fractions, we don't need a common denominator, but in this case, we actually can reduce things. 5 over 15 is 1 over 3. 4x over 2x is 2x over, 4x over 2x would just be 2 over 1. So I end up with 2/3. So just like doctors in surgery, pay close attention to perform the correct operation at the correct time. Alrighty, so for tonight, section 7.4, I will be back this afternoon at 1:15 if anybody has any questions. Otherwise, I will see you all tomorrow. So I'll stop the recording